Minecraft, a game that no one on YouTube has ever attempted to make before. I've heard it said that making Minecraft is actually not that difficult. Making Minecraft run well, on the other hand, is very difficult. Today, on the 20 Games Challenge, we made Minecraft. Yikes. Most people don't have any idea how most games are made, and yet the fact that Minecraft has chunks seems to be a very common knowledge, which results in most of these videos having a very similar format. We'll always start these, Minecraft in a day or whatever challenges by making a bunch of blocks and usually using physics objects, and then put them in the scene and then complain about the performance, and then we'll go and make a mesh like this. You may have heard before that Minecraft uses voxels. That's only partially true. So if you remember from my asteroids video, we talked about the difference between vector and raster graphics. And raster graphics are made up of individual pixels, or more accurately, cells in a two-dimensional array. Each of these cells contains colored data, and if you zoom in, there are a finite amount of pixels. So you end up with a very blocky image when you zoom all the way in. Raster graphics are not infinitely scalable. On the other hand, there are vector graphics. And so this is my ship from asteroids. If you zoom all the way in on this, there are no individual pixels. This is mathematically defined shape. And we can do the same thing in 3D. Back in the early history of video games, there was a question of how are we going to do 3D graphics, and one potential solution was voxels, which are essentially a 3D pixel. It's the exact same thing as raster graphics, except you are representing a cube in space instead of a square in a 2D image. So you may have heard that Minecraft uses voxels for its terrain. It does not actually render as voxels. It converts each individual cube on the Minecraft terrain into triangles in a mesh, and that is exactly the same as any other 3D graphics. There is nothing special about the graphics Minecraft has. So no, Minecraft doesn't use voxels. It does use, let me double check. It uses voxels. So apparently this is one of the situations where the misconception became a convention and eventually became a definition. Voxels don't just contain colored data anymore. Voxels contain any data in a simulation, or in this case in world generation. So Minecraft, no, does not use voxels for rendering, but the terrain itself is stored in a 3D array, and those are voxels. Just a little interesting fact on that one. And that leads to the question, well, then how are chunks rendered? In this case, it uses a mesh, and that mesh is made up of triangles. That's how every 3D video game works. Kind of interesting misnomer there. But with that, what we'll do for making a single block is we have 8 different points that we'll define in space. And we will take then, so here the back is actually facing towards us. If we look at this back, it's defined by 4 points. It's 6, 7, 4, and 3. So we have these points sitting in space. If you imagine taking these and adding them to whatever the position of the block is, right? 0 would be the base of the block. We'll add in these extra vectors to displace. And so then we will have these 4, and we pass that into a function down here called create face. And we'll do this 6 times, 1 for each face. But just looking at the back face, we have this 6, 7, 4, 5. We then come down here and we pass them in 6, 7, 4, 5. We're going to connect this. We're calling them A, B, C, and D. And an important part when you're connecting these up, B, C, D, and B, C, A, and B, D, C. And the way that those are connected is very deliberate, where when you draw a triangle, it needs to be clockwise in this one. The reason for that is faces are only one-sided. The graphics card wants to be as optimal as possible, so it will not present textures on both sides unless you tell it to. So if you get this backwards, it won't look like it's doing anything until you get inside the object, and then you'll get this weird visual anomaly where you can see things that you're not supposed to, but you can't see things you are supposed to, and it's kind of strange. So that is the way that we do that. So we're going to kind of abstract that away. But that said, when I come back and do this for the part 2 of this video, I'm going to be making 3 other methods of creating a chunk. It's kind of this weird question of Minecraft is, 11 years old? Why are we still making it that way. Wouldn't a modern game engine, isn't there a better or more modern way to make this? So I don't know the answer to that, but I am going to try making not just the Mojang approved way of making a chunk, but also having a few other attempts, and we're going to compare performance. So that'll be later. But for now, we have a block that is being made, or a chunk that is being made, rather. The next part, once I had a few blocks together, I just place these in the scene. There's no generation of multiple blocks, but each block will be generated and I'll place them all in the scene. And so once they're there, the next part is going to be to make a player controller. This is another thing I didn't really feel very confident with. I've done 2D, but for the most part, my players are moving relative to the camera. If you think of a platformer, up is up, left is left, the character will move in whatever direction you press. For a first-person controller, forward is relative. So I didn't feel confident, and I thought I could just punt and make a controller that I'd come back and fix later, where you are moving in absolute X and Y coordinates, and the camera's fixed, and I was just going to use that and then move on to chunk generation. However, by the time I got that done, I had done a little more research and decided that it was probably worthwhile to just stop and actually make this thing work. It turns out it's not actually that hard. The big thing is to use what's called a basis, and that is relative coordinates. So if you imagine a vector, right, a two-dimensional number essentially, but it will be some portion x and some portion z, but it will represent a normal vector, so a vector with a length of 1 in your x direction or your z direction. So you can take this basis function, you can take basis.z, and it will give you this vector that you can then move by or multiply by an amount, and that gives you a movement vector. I don't remember how this was done in Unity. I remembered it being a lot more complicated than this. It may have just been because I didn't know as much back then, but this was definitely quite simple, and I was quite happy with how quickly it came together. The other part was looking around. I used the mouse here. I also have it mapped to a gamepad controller because I like playing and testing with a gamepad. So they'll be both, but whether you're using the controller or the mouse, you are going to be looking. I have these functions I'll pass into, rotate head function, and it will take the left and right amount and the up and down amount from either the mouse or the controller. And what it will do is it'll rotate the actual character, so the player's body around to the left and right, but there is a separate head element. So here you see there is a capsule that is the player and there's a cube that is the head. And the camera and a ray are both attached to the head. Now this ray will be used later to detect where a block is. Whenever it detects a collision with the block, it'll do a little bit of math to determine that that's the location where you need to either place a block or remove a block if you right or left click. Those are both attached to the head. So the ray's always in the center of the camera and the head will tilt up and down, but the body will rotate side to side. So both of those together will combine to give you your full range of movement. So that was the big scary part of transitioning to 3D. We're still going to be dealing with 3D, but for the most part, we're going to be thinking in terms of 2D for a lot of this stuff. So now that I have a player together, the next part is going to be to load more than one chunk. So I have an individual script called chunk, and this is one, it's 16 by 16 by, I think it's 128 is what I end up going with. That is all configurable, and it just loops through the numbers. So you can make it as big or small as you want, but one chunk. And the world is going to be made up of a bunch of these. So instead of adding stuff to this script, I'm going to have a script that will instantiate all the individual chunks. And this is essentially, I probably could have called it chunk manager. I just called it chunks, but it will load. So it's given a player position. And this is, if you notice, a vector 2. So in the game script, we will take the player's position and we're going to convert it player position to chunk position. But this is a simple conversion where it'll round it down and it'll make it these will be integers, an x and a z. And from this point forward, we're dealing with essentially vector 2s. Because we're not stacking chunks in 3D space, we are only going with the chunk height, just like Minecraft does, at least used to. I think it still does that, where you have a maximum height. You can't just keep climbing indefinitely. So we're going to be dealing with chunks in 2D space from here on out. But we will want to place it, and then we'll do a simple conversion back just by multiplying by the chunk size. And we're just going to loop through a square around that chunk, and we're going to build the chunks one by one. So we start by doing this in the main thread, and it is obviously very slow. So I get it up and running, and I'm instantiating the chunks in the right place. They're just loading flat. We're going to do that for a while. The next thing I'm going to do is I'm going to do threading for the first time in Godot. And actually, threading and noise are basically going to be the rest of the video. And this is actually a really fun project for me. I am a firmware programmer by day, so I spend a lot of time on low-level system optimization, and I'm actually trying really hard to not optimize or prematurely optimize on this project. You will see a lot of things, especially when you get into the world generation, that I could do better, partially why I'm making a part 2. But I've gotten in trouble before with optimizing something before checking if it needs to be optimized. So I'm trying to not do that on this project. With that said, a lot of the things I've done on the 20 game series has focused on art or music, or some of these things that I'm not very good at. But there's a lot more to learn about the Godot engine than I've used so far, and this is a really fun opportunity to dive into those things. So threading is something I have done in general, but have not done in Godot. And threads are kind of like children. They're not really that complicated to make, but once you have one, it's very difficult to prevent it from barfing everywhere and making a huge mess out of everything. So I had some thread problems, and I had to rewrite this 3 separate times. My first take wasn't bad, it just wasn't very efficient, and I decided to redo it, which was partially the optimization wormhole I should have known to avoid. My first take was I didn't want to just have a second thread that loaded chunks. I wanted to be able to utilize all the cores on my computer, so I wanted to have up to 16 threads running. And I thought, why don't we just, each time we're going to load a few extra chunks, every time you're walking, as you pass from one chunk to the next, it's going to trigger and it's going to call this chunk script, and it's going to say, I need you to load chunks. And it'll then go through, it'll run through this loop, and it'll check what chunks are new. If a chunk already exists, it'll just stay there. If a chunk leaves the render distance, instead of deleting that, we're just going to turn it off. And we're only going to delete chunks when we start to run out of memory. So we don't need to remake chunks that already exist. If you think when you're playing Minecraft, quite often you'll be walking in a straight line, you'll turn around and you'll walk back the direction you came. So with that, we have the chunks that you already walked through. They will be deleted. The oldest ones, so hopefully the farthest away, will be deleted first. So if you have a good amount of memory to spare, you don't have to create very many chunks if you're wandering around instead of just walking in a straight line. So with that said, we are going to be loading the new chunks. We'll usually be loading, depending on your render distance, say you can see 10 chunks, you'd be loading 10 chunks at a time on the edge. I do round this off later, so I will actually double check and I'll load it in a circle instead of a square, just so those corners aren't being unnecessarily loaded, but I'll be loading them. So my first thought was to, each time you load new chunks, I would spin up a new thread for those chunks. And assuming you haven't exceeded your thread limit, each time you cross a border, it'll run through this load chunk script, and assuming you're walking to a place that hasn't been loaded before, it will check all the chunks that need to be loaded, it'll put them in an array, and it'll pass them on to a new thread, and that thread will run through those chunks, and it'll build them, and it'll attach them to the scene. You actually need to use call deferred to make sure that they are being attached on the main thread, and then the thread ends. And that's where this gets a little messy. With Godot, you can't just leave a thread lying there. You need to actually call a function called wait to finish. And this waits to finish, so you want to call it after the thread has finished so it doesn't wait long, but you need to do that on the main thread. So I decided to pass the thread a copy of itself, and then it will use a call deferred to call a function back on the main thread by passing itself as an argument so it can shut itself down on the main thread. And that's about as messy as it sounds. worked. It didn't work well, and I quickly decided I would want to rewrite the entire threading system. But before I did that, I thought I would stop and do a little bit of random terrain generation, so I'm not just working with these flat chunks. With the basis of a game together, I'm going to set up the world generation script. I already have a individual chunk being generated, but I decided I want to abstract away the noise bit. So I made a world gen script which will have a function that will get a block type for any location in the map. And the way I'm going to do this is using simplex noise. I talked about this in my last video, but simplex noise, the short version, it basically will generate clouds. So if you think of, they're higher and lower density, but it's very smooth noise where you don't get random static like a traditional noise function would give you. It gives very smooth and gradual movements. So using that, you can very easily, if you sample a 2D noise and then use that value as your height, you can get these smooth rolling hills. So I did that, but I did it using a function called getBlockType that will take the position in absolute world space. So the X, Y, and Z unique index of this block, not just the block within the chunk, but overall, and it will return what that block is. And it does it in a way where it doesn't matter what you were doing before. You can ask for any block anywhere in the world, and it'll know what it is, and it'll be able to tell you. So that's the basis of my world generation is I wanted to have this kind of absolute function or class that would know the entire world and be able to tell each chunk what the blocks are going to be. So that'll happen in the first call, the chunk generate, and it'll go through all this and make them. And then the update is just the part of taking that data and actually turning it into something visible that you can see. I realize as I am looking back on some of the things I made, I did not optimize anything. But again, premature optimization is almost always a bad idea, and I will be coming back and adding more. But I wanted to get it to work, even if it doesn't work well. And obviously, it doesn't work well, but we'll be fixing that in the future. But for now, I am getting it set up, and I really wanted to make that where the getBlockType function, it doesn't matter what you've done before. It is entirely decoupled from anything else that's calling, any past or future calls. It is always returning the same thing for the same block, no matter what, no matter when it's called. So I got that together, and that was about all I got done. Essentially, this is a working game. I also added placing and removing blocks. That would just change the type of a block at the location where the player is pointing, either turning it into air or turning it into, I think I used stone right away. I will turn that into some other things later, but that was just a lot of vector math. So I'm not going to spend too much time on that. But essentially, this is Minecraft. I have it done. I have it working. And I could end the video here, but again, this project is my chance to really dig into some more advanced techniques in the engine. And one major thing that I think is huge with Minecraft is the generation looks really cool. I see a lot of the Minecraft clones I see people make don't get that right. And I actually watched a GDC talk recently from the creator of No Man's Sky who was talking about generation, and it really got me thinking. I want to spend some time trying to make something that feels a little bit more Minecraft in that. So we're going to spend a lot more time here. But before we do that, I'm going to dive into the threading one more time, or I guess 2 times in a row, and rewrite it twice. This is probably one of those things I didn't need to rework, but I wasn't quite happy with my solution. If you remember the first time I did this, when you cross the boundary from one chunk to another, the game will call a function called load chunks, which will look through and find any chunks that have now entered your view radius. And it'll put all those into one array and send them to a single thread. And that thread will then, one by one, build those chunks and add them to the scene. I had a number of problems with this, but one problem in particular is if you have a large view distance, say 20 chunks, you can have one thread trying to make 20 chunks. And if you are walking in the right direction at the right speed, you can get there before that thread is finished. even if you're not hitting the thread count or the thread limit, you are essentially faster than that one thread can keep up with. What would be nice is if we had all of the threads that our system can handle working at the same time. This is where I made a mistake with not knowing how threads work. I thought that it would be a bad idea to start and stop threads all the time. So instead of doing a simple solution, I tried to set up a number of threads that are always running and always waiting. And when you have chunks to generate, they will all pick those up on their own and start working on them. One thing you should know about threads, I said before, the analogy threads are like children, they hate sharing. So if you have an array that you are loading up with data for them to work on, they will destroy each other and everything and have a meltdown if you just let them access that and pick up things as they want. They'll start fighting over it. They'll both work on the same one and not know it. There's all sorts of messes. So you have to use a couple tools called mutexes and semaphores. And a mutex is basically saying one at a time. It's saying, okay, everybody gets to ask, and it's asking them to raise their hands. And it says, I'm going to call on you. You get to go grab your data. And then once you sit back in your seat, somebody else can go. And it is a good organization technique, but if you don't plan ahead, like I didn't, it becomes a huge mess. So I had mutexes being called and released everywhere, and I was getting deadlocks and all sorts of threading issues. Threading is something that a lot of computer programmers hate, and this is the reason. I totally did it to myself. I shot myself in the foot. I spent multiple hours on this, and it turned out I was doing something that was too complicated. There's no reason to do it that way. It turns out threads are, I couldn't find much data on Godot in particular, but when I was Googling around, just in general, threads are not very expensive to create. And so instead of having threads that are always active waiting for data, I can just create a thread when I have data to give it. So I decided to do a final redesign. I added a function that will just run on the process thread where I keep an eye on how many threads I have currently. And if I have threads available, I will go to that array of chunks and I will grab the next chunk to process. I will create a thread. I'll give the thread that chunk. I will have a function that stays alive. It'll just continue to yield for idle frames. Once every frame, it'll just double check, hey, is the thread done? If not, it'll just keep waiting. Once the thread's done, it'll call thread to wait to finish, which cleans up that thread. And then it'll do all of the stuff that I was trying to use mutexes to protect on the main thread. So the most important parts, the finalize call, which will add child elements to the scene that can only be done on the main thread, adding the chunk itself to the main scene, and a couple other little things, and then also adding and removing to that array, that all is done on the main thread. So there's no conflict anymore. This is a much better solution. So the downside is we are generating a thread per chunk, and then we're cleaning up that thread when we're done. But the thread runs for a good fraction of a second. Seems like up to a second by the time I'm done. I really need to optimize this. But it works a lot better. So that was my final solution. And all the thread does is it calls the generate and update functions, which is the slow part of my code. And everything else is done on the main loop, and everything else is really quick. So that was that, and I finally got threading fixed, and I feel pretty happy with my final solution. I realized I can clean it up more. I probably will remove that array, but that will be a future update for my next video when I'm focusing on just performance. For now, threads are done, and we get to move into the final and most fun part of the game, which is world generation and noise. Now we're going to look back at the chunk generation one more time. I have been using just that one instance of simplex noise, but it would make sense to be able to do more. I have this world generation script. It's decoupled from the chunks. I think it would be really cool to do a little bit more with it. So the next thing I do is I add a second simplex noise for one for hills and one for plains, which is going to be able to give us, instead of one kind of boring looking default that's the same everywhere, we're going to get some variety because we're going to have two different levels. If you've seen open simplex noise used in games before, this probably looks generic, even if you didn't know what it was that they're using. Once you have seen it a few times, there is definitely a look to this. So having two starts to make it feel a little bit more like classic Minecraft that I played. There is still a problem though. We have all this noise, but how do we blend between them? If you have the hills biome and the plains biome and they're different, what do you assign each chunk a biome? If so, are you just going to have a cliff wall between them? What I ended up doing was adding a third noise that was called biome noise, and it's going to be a blend of the two. There's still a problem with that though, because if you imagine one extreme is hills, the other extreme is plains, basically everything is going to be in between the two, which means essentially you don't have biomes. So I added not just noise, but a curve, which is my biome transition curve. And if you look at this curve, it is entirely zero up until pretty far along, and then it sweeps up and becomes one, and then it stays at one for another good while. So if you imagine your simplex noise is bouncing back and forth between these two extreme values, but it will essentially throw it to one extreme or the other for the most part. So that'll result in absolutely one biome and then absolutely the other biome with areas of blending between them as they transition from one to the other. So we'll add the heights together. We actually use the lerp function for this, linear interpolate. I was doing it by hand with my math, and then I realized that what I was doing was just linear interpolating. So we'll pick a value between entirely one and entirely the other, but we use this biome transition value pass through a curve and then use that to linear interpolate between one and the other. And that gives us a much more smooth total height. We're also going to use that on the next part. So far, as I said, everything is entirely separated. It doesn't matter what you've been doing before. If you get a block, it'll tell you what that block is. That all is going to break down with the next thing because I decided this game wouldn't be complete without adding trees. That's quite an iconic part of Minecraft. And just, this is a place where you can pause the video and think about this. How would you make a tree? Think about it. So far, I have a function for get block type that is entirely independent of everything else. It'll just tell you this is stone, this is dirt, this is grass. It does it by sampling the noise textures. It doesn't matter where you are in the world. But how do you tell if the block is, say, a leaf of a tree? You have to look below it somehow and figure out where the tree is, maybe? I don't know if there's a way to do that. But my answer was just a punt. I switched it up so the chunks now generate from the top down. And when you are at ground height +1, it will check if you are a tree. So it will generate essentially just the stump, the very bottom part of the tree. And I'm actually going to pass that, once I get that working, I'm going to pass it as a new type of block that isn't actually a block. It's just called stump. If it returns stump to the chunk script, that'll tell the chunk that this is the beginning of a tree, but it needs to go back and overwrite blocks that's already written. I ended up writing a function called getTreeDimensions that will determine a lot of things. So I have the height of the trunk, I have a brim and a top, which are the two parts of the tree. I have their height and their width, and I'm going to define all these randomly. So as I return a tree, it's not always going to be the same. They're going to be a little bit different. So with that, I now need to, in the chunk itself, I need to have a generate tree. First, it'll just double check that you can make the tree. I'll look up 6 or 7 blocks, make sure that they're all air. What that'll do is it'll make sure that trees don't spawn into each other. I didn't have this at the beginning, and there are a lot of clusters still, and that doesn't really look realistic when you have 2 tree trunks right next to each other. In the real world, if one tree is growing, other trees won't grow in the shadow of that first tree, at least not very often. So I did that to make the spacing feel a little more realistic. There's another problem, this is subtle, but how do you solve the issue of a tree generating on the edge of a chunk? Think about that. You need to have leaves that are placed in the adjacent chunk. My solution was to just not do that. So the world generation script will place a stump anywhere in the world that it deems valid, but the generate tree function will double check. And if it is next to the edge of the chunk, it'll abort. It'll say this tree is not going there. And you don't really notice it when you're playing the game, but if you pay attention very carefully, you could see that trees never cross that line. But they do grow up next to it, and because they grow up against each other, I never noticed a pattern where you could see the grid in the forest that I made. So that was my solution. I just don't go into adjacent chunks. Again, I could have solved this differently, but that was the easy way to do it. So now we are placing a tree. We're going to sample that randomness. We're going to put the tree in place based off of it. Problem 2. How do you make this repeatable? Remember, I am sometimes deleting chunks and then I need to recreate those chunks. And you don't want the world to look different when you come back simply because it was deleted from memory. But trees aren't using simplex noise. If you think about it, simplex noise is, like I said before, kind of clouds. For trees, you don't want to have 100 trees right next to each other. You want them to be kind of spread out. So I do use simplex noise to make a general tree distribution map, but within that, I need to use a standard noise function to decide is a tree here or not. That makes it a lot more truly random. But if I'm calling this randomness, remember I have multiple threads calling this script. You don't know who's calling what when. And this randomness, there's not really and there is an order to it, but you don't know what that order is if multiple threads are interacting with it at the same time. So again, this place to pause the video. How would you solve this? Again, I kind of punted on this a little bit. I decided the best solution was to add a function at the beginning to start a new chunk. So now when the chunk is going to call the world gen, the first thing it'll do is it'll say start a new chunk and it'll return chunk data. This is a black box. It doesn't know what it is. It's actually a random number generator, but the chunk doesn't know. And every now and then the block will say, hey, give me that chunk data, specifically when it's getting the block type or getting the tree dimensions. And because this is going to process the same way every time, this is something that is repeatable, nothing's different here each time, it will call the same randomness in the same order. And now the critical part of that is when I start a new chunk, I'm going to take the world seed and I'm going to add a hash of the chunk's position and assign that as the seed to the random number generator. If you don't know how random number generators work, they're not actually random, they're just an algorithm. And based on the seed, they're going to give you some data that hopefully looks random, but it will be the same data every time based on the seed. So if you reset the seed of a random number generator, you will get the same values every time. I actually set my global seed to 10, just a random number I picked, but because I wasn't mixing it up every time, when I load into the game, it looks the same every time, which really does help me with playing with randomness because you can see how the same world looks when you change these values. So I did that, and now each chunk gets the same seed each time. And based on that, the trees will randomly happen in the same order every time the chunk's generated. And because the chunk is holding on to its own random number generator, it never shares that with another chunk that's being generated. And that fixed all of those problems for me. So that's how I ended up doing the trees. At this point, I am starting to stretch the definition of one day. I'm nearing the 18-hour mark, which is my final limit. But I really want to get caves in because I think if I'm generating a world, a Minecraft world in particular, caves need to happen. So there's another little trick you can use with that. I've so far been using simplex noise, but I've always been sampling the noise in 2 dimensions. You can actually sample that on multiple dimensions, even more than 3, but we're not going to go that crazy. I'm going to use 3 dimensions. We'll just compare it to a random value, and then we are going to say it doesn't matter what this would have been, even if it's underground, the block is now air. And that's essentially how I'm making my caves, is by putting the sky in the ground using simplex noise in 3D instead of 2D. So that'll give a lot of holes is what it causes. This is a good start, but there's still a problem here. You can see all the caves reach the surface and they reach the bottom. There's holes in the ground, there's holes in the top. The solution I came up with that one is to run this again through a curve, just like I did with the biome blending. I have a cave spawn chance that based on the depth you're in, I'm actually made this essentially a percentage between the absolute bottom of the map and the height of the surface of the ground. There will be a chance that a particular block is a cave, but that chance is then going to be combined with the 3D noise, which means you're going to get these, kind of cloud shapes that Perlin noise makes, but it will be larger or smaller based on the chance, which means as you get to the bottom, you're going to end up in the plains. I decided to go with more like caverns. In the real world, caves are less common in flat areas, but where they do exist, they're usually quite cavernous. And in hills, I used to go splunking in Colorado. Okay, I went like once, but still, it was very fun. They're very small, kind of claustrophobic caves, and they're a lot more windy just because the way the terrain is results in different kinds of caves. So I made two. I have the large caverns in the plains, and then the small, windy caves in the hills. And again, I'm interpolating between those two biomes based on the biome percent. That's the same as I was doing before. But the big thing here is the caves will also run through this cave chance. And there's a curve. So what we're going to do is we're going to get these little tiny holes on the surface, because the value you get from the simplex noise is going to have to be very high in order for a cave to actually exist. And that doesn't happen very often. So you get these little holes, but once you jump into them, the chance that it is a cave gets a lot higher, which means the simplex noise can be a lower value, which means you get these wide open spaces, which I think are really cool to fall into. So for the caves on the hills, because I'm going to use different values for this, you're going to get these tiny little, places that are kind of hard to get through. Now, we don't have caves that are really long. I feel like in Minecraft, they aren't quite so random. And I do have some ideas on how to fix this. We'll see, no promises, but I might do that in the next video. But for now, I am, with the little time I have left getting this together, I think it really completes the game. The final thing is I have been using the default world environment up till now. And this is because I tried a couple times to add the world environment and it just is, I didn't know how to use it. So I sat down and I spent some time messing around with it. It turns out the world environment does not contain the sun. That was my mistake. I kept going in and trying to change settings and everything looked terrible. Just like, why does this node always look terrible? You'd think that they would make it look good by default. Yeah, it turns out I was using it wrong. And boom, it looks so much better now. We have shadows, we have fog, we have fall off. I had blur, but I couldn't really tell if it was doing anything when you also had fog, so I just turned that off. But yeah, now you can't see the edge. I do change the draw distance for the camera to match the fog. And then I also went and added a little bit of script. So when the game starts, it'll double check what your render distance is, and it'll set the fog and the camera distance based on that. I actually might want to do more with that as I'm going to do some optimization. I've been thinking about techniques where I might be able to render starting from the player's location at all times. And based on how many chunks are being drawn, the fog could extend that far and no further. I think that would be really cool. So that's going to be my next video, as I said. But for now, this is Minecraft. And yeah, I'm just going to show you my final product. I am quite happy with my first 3D game. Yeah, I know I never got water done, but hey, can't get everything. Another thing, for some reason, I couldn't get transparent textures to work either. When I turn it transparent, the entire world starts going crazy. I looked it up and I guess transparent textures are rendered differently. So I'd actually need two separate textures. Transparent ones can't be a part of the same sprite sheet, or maybe they can, but you have to import them as a second actual texture object. I don't know. So I just ended up filling in the leaves to make them solid. I also had a few small bugs and issues that when I was getting the world environment set up, I fixed. And yeah, here's the final game. We'll just walk around. I don't know, maybe put some music. Yeah, quite happy with it. So yeah, thanks for watching. This is Minecraft in Godot.